The flyweight pattern is a structural design pattern that aims to minimize memory usage by sharing common states between multiple objects, allowing for efficient handling of large numbers of lightweight objects with shared characteristics. So say that we have a farming game that includes different types of crops, such as potatoes, carrots, and wheat. And each crop is represented by a crop object that includes its X and Y coordinates, the crop type, and an icon for that crop. So here is the UML with its x-axis position, y-axis, the type of the crop, and an icon. And the crop type you can see here is an enum, which will have type of either potato, carrot, or wheat in our example. And we have an icon, and icons can be represented by an array of bytes. Okay, so here we have our crop type enum, which can take the value of either a potato, a carrot, or wheat. So these are the three crop types that we have in our game. So let's now go ahead and create the crop class. And a crop has a position on the screen, so an X and Y coordinate. It also has a crop type field. And it also has an icon, which we can represent as an array of bytes. Okay, so let's now create a constructor for this crop class. This needs to be of type crop type, and then we can set the values, set the fields, and finally this crop class needs a render method for rendering the crop onto the screen. So I'm just going to log drawing the crop type at the position of X and Y. Okay, so that's everything we need to do for this crop class. So let's now create a crop service class, which is essentially going to be used to fetch our crops. And these are going to be stored in probably some database. Okay, so let's create a method called getCrops. And this is going to return a list of crop objects. Okay, so let's first of all create a crop list. And then let's simulate fetching our crops from a database. So here what we can do is we can create some crops. So I'm going to say var carrot equals new crop, and we can say it can be at position 1, 4, and it can be a crop type of carrot. And I'm just going to pass null for the icon just for convenience rather than creating an actual array of bytes. So let's also create a few more carrots. So let's just call this carrot 2 and carrot 3, and let's just change the position that it will be rendered on the screen. Okay, so that will do. So that's kind of like simulating fetching our crops from a database. So next thing we can do is we can add these crops to this crop list. So we can call crop list dot add, and then we can add a carrot, and then we can also add carrot 2 and carrot 3, and then we can return this crop list. Okay, so you can see this kind of crop service get crops method is just sort of simulating what we would do in a real application, which is probably fetch the crops from the database and then return the sort of list of crops. And each crop knows its position that it should be rendered, its type of crop, and also the icon for that crop type. Okay, so using this solution in a client now, so if we go into our program.cs file, we can first of all create a crop service. And we can then loop through our crops and render them on the screen. So we can say var crop in crop service dot get crops, and then we can just call crop dot that should be crop dot render. Okay, so now if we run this program, we can see that we are drawing all of our carrots at the correct position on the screen. So the problem with this solution is that for every carrot or crop that we create, we are storing a new object with all of the information about a carrot stored within that object. So this means that if we create 1000 carrots, then we'll be storing 1000 carrot icons in RAM. And that's going to take up lots of memory, and many mobile devices will struggle to handle that. So if we actually have a look at the crop object, we can see that this takes up 4 bytes. So integers take up 4 bytes. This is 4 bytes. The crop type is also 4 bytes. And the icon will be around 40 kilobytes. So if we actually create a new icon for every single crop that we create, if we have, say, 1000 crops in the game, that will be 1000 times 40 kilobytes, which is 40 megabytes for 1000 crops. And that is a lot of RAM for smaller devices such as mobile phones, and the game may slow down, lag, or crash. So this is not ideal. So what if we could share icons between crop objects of the same type? So if we have, say, 300 carrot objects, what if all of those carrot objects could share one single carrot icon rather than creating 300 of the same icons? So if a carrot is created with the crop class, then its icon and crop type fields will remain constant for the lifetime of the object, but its x and y coordinates will vary as the crop can be harvested and moved around. So state that remains the same throughout the object's life is called the internal state of the object, and state that can be changed is called extrinsic state. So you can see within our crop object, the x and y coordinates are dynamic. They can change throughout the crop's life cycle. So these are called extrinsic state. And the crop type and the icon are constant throughout the crop's life cycle. So a carrot is never going to become a potato, and a carrot is also never going to look like a potato. So this is constant, therefore we call it the intrinsic state of the object. So if we can extract the intrinsic or constant state out of this crop object or crop class and place it into a new object called crop icon, then we would only need to create 3 crop icon objects for potato, carrot and wheat in our application. Even if there are thousands of crops in the game, we only need to create 3 of these crop icon objects, and this is going to save a lot of memory. So we can then, for example, just have 1 carrot icon object stored in memory. Then all crops of type carrot can reference or reuse that carrot icon object throughout the game. So you can see here we have our crop with its x and y dynamic fields, and it's composed of a crop icon object and only one of these crop icon objects are going to be created per crop type. So carrots are going to all share a single crop icon object for carrots, and potatoes will also share a single crop icon object for potatoes, etc. So an object, again, an object that contains only intrinsic state is actually called a flyweight object. Okay, so let's just remind ourselves, the intrinsic state is the constant state, and you can see here an object that contains only intrinsic state is called a flyweight. So this crop icon object is going to be our flyweight object. But it should be noticed that we shouldn't create crop icon objects directly. So we can create a factory class that creates an icon depending on the icon type and caches that icon in memory, ensuring that it's only stored in one place and ensuring that it's only created once. So here is the overall structure following the flyweight pattern. So we have our crop with its extrinsic state, we have our crop icon with the intrinsic state, so the constant state. We then have a crop icon factory, which is essentially going to ensure that crop icons are only created once per crop type and stored in a single place in memory. And then we have our crop service, which is going to sort of simulate getting our crops from the database and creating a list of crop icons. So here is the gang of 4 representation for the flyweight pattern. We can see that we have our flyweight object with some sort of repeating state. We then have our flyweight factory, which caches flyweight objects, ensuring that they are only created once. And then we then have our context, which in our case is like our crop object with its unique state or its dynamic state that's going to change. It stores a reference to the flyweight object, and we then have some operation, so flyweight.operation with its unique state. Okay, so let's now implement this flyweight pattern for our farming game. So we are now going to refactor our code to follow the flyweight pattern, and we're going to basically store these fields inside of a separate class so that it can be cached in memory and we don't have to create multiple icons for the same crop. So we still have our crop type enum, so nothing's going to change there. But inside of our crop class, we no longer need these fields. Okay, so we're actually going to instead reference a crop icon object, which we haven't created yet. So VS Code is going to give us an error, and let's call this crop icon. And inside of our constructor, we can again remove these fields because we're not going to pass these anymore. We are instead going to pass a crop icon, and VS Code is going to give us again an error, and we can set this crop icon equal to crop icon. Okay, so in here we no longer have direct access to this crop type field, so instead we can call crop icon.getType because we are going to provide that method on the crop icon object. Okay, so that's everything that we need to do in our crop class, and we now have some errors that we need to fix. So let's go ahead and create the crop icon object. Okay, so this is going to be our flyweight class that stores intrinsic or constant state, the state that remains constant throughout the object's life, whereas our crop class is storing our extrinsic state or our dynamic state that is going to change throughout the object's life. So in here we can store two fields. So we're going to store the crop type, and we are going to store the icon, which is going to be, again, an array of bytes. And what we can do is we can actually make these fields read-only to ensure that once they are constructed, they cannot be changed. So let's make those read-only. Okay, so let's create our constructor now. Okay, and remember we also need to create a getter for the crop type so that we can get the crop type inside of our crop icon, inside of our crop object. Okay, so I think that is everything we need to do here. So now we need to create our crop icon factory class. So this class is going to ensure that each unique crop icon object is created only once, it is cached and then reused or shared between the crop objects. So first of all, let's create our crop icon cache. So this is going to be a dictionary, and in here the key for the dictionary is going to be crop type, and the value is going to be the crop icon. Okay, so now let's create our getCropIcon class, which is going to essentially ensure that icons are only created once per crop type. So here we are going to return a crop icon. That should be crop icon, and we're going to call this getCropIcon, and it's going to take a crop type that we want to get the icon for. So if we want to get the icon for a carrot, we can pass crop type.carrot into this getCropIcon method. So first thing we need to do is we need to check if the icon already exists inside of our cache. So I'm just going to make a little comment here to say that this is our cache. So what we can do is we can say that if icons, and this needs to be negative, so if icons does not contain key of the crop type, then that means that the icon does not exist in our cache, which means that we need to create one and add it to our cache. So let's create an icon. So var icon equals new crop icon, and we can pass the crop type, and for the icon I'm actually just going to pass null, and I'm just passing this again for convenience, but this could be, for example, a reference to some file location of the image. But just to keep things simple, I'm passing null for now to not make things too complicated. So once we've created our crop icon class, we can add this icon to the dictionary. So the key is going to be the crop type, and the value is going to be this crop icon object. Okay, so finally, if we get to here, we know that the icon exists. So the icon either already existed, so this wasn't necessary, so this conditional, we just skipped this bit here, or if the icon didn't exist, we created a new one. So if we get to here, we know that we have this icon, so we can return icons and access the crop icon object via its crop type key. Okay, so this all is looking good. So we now have our crop icon factory, which is ensuring that each crop icon object is only created once per crop type. Okay, so finally we can come into our crop service class and we can now do some refactoring in here. So crop service needs to store a reference to the crop icon factory. So we can create a field called crop icon factory, and we can call this icon factory, and we need to pass this via the constructor. Okay, so let's have a look at our get crops method. So we are storing a list of crops, so we don't need to change this, and then we simulate fetching the crops from the database. So this is where we need to make some modifications. So we can see here that now in our crop class we are no longer passing the sort of constant state, okay, because this is now stored in our flyweight object. So instead of passing the crop type and the icon, we now use our icon factory to create a crop icon object. So we can say icon factory dot get crop icon, and then we pass the crop type that we want to get. So we can say crop type dot caret. Okay, and all of these carets now are going to be sharing the same crop icon object, which is stored in cache due to our icon factory. So this is exactly what we want. And then here we add our crops to the crop list and return the crop list. Okay, so now let's go into our program.cs file, or our sort of client, and let's see how we now use this new solution using the flyweight pattern. So here we create our crop service, and we can see we have an error here. So there is no argument given that corresponds to the required parameter icon factory of crop service.crop service crop icon factory. So you can see here that we need to pass a crop icon factory. So let's go ahead and pass that in. And we are now doing exactly what we did before. We are looping through our crops and we're calling crop.render. So as you can see, there's not much difference in the way clients use this class. We just, the way the client uses this solution. We just now need to pass a crop icon factory to the crop service to ensure that, so that this is actually handling the creation of crop icons. Okay, so now if we run this file, run this program, you can see that we get exactly the same as what we did before, which is perfect. So to summarize, we have created 3 caret crop objects, but only 1 caret crop icon object. So this solution will save lots of RAM when rendering many crops at one time.